Section 8-1 is all about solving equations with two variables. So far in this class we've only seen one variable expressions, equations like this or like this, that you solve and you get a solution that looks like x equals 2, or in this case m equals 4 or negative 1. You get one value for the variable, or maybe two values for the variable. In this section we're going to have equations like x plus y equals 7. For these equations there are many answers, and the solution is a value for x and a value for y. So we write these as ordered pairs. One solution to this equation is if x is 1 and y is 6. So we would write the solution this way. If x is 1 and y is 6, 1 plus 6 is 7. So this would work. Another solution would be 3, 4. The ordered pair 3, 4 means if x is 3 and y is 4, this equation is true. So the difference between one variable and two variable equations is the way that the solution is given. And here I just need one value for the variable. Here I need a value for both variables. The last example here, I have two different variables. In this case, they're a and b. I'm still going to write their solutions in an ordered pair, but I'm always going to think of the first number as the a and the second number as the b. It's always going to go alphabetically. So an example of a solution to this one would be like 1 and negative 1. If a is 1 and b is negative 1, this equation. To determine if an ordered pair is a solution to a given equation, what we're doing is plugging in the values. Okay, so here's my example. 3a minus 2b equals 13. Is 3, negative 2 a solution? What we mean here is that if a is 3 and b is negative 2, do these values make this equation true? Well, let's plug it in. 3 times 3, because a is 3, minus 2 times negative 2. Is this equal to, so I'm going to put a question mark, 13? Well, 3 times 3 is 9, minus, this is negative 4. 9 minus negative 4 is 13, so we're going to say that yes, that is a solution to the equation. Let's try the next one. The next one is 5, negative 1. So we're going to plug 5 in for a, so 3 times 5, minus 2 times, well, b is negative 1. Is this equal to 13? Well, 3 times 5 is 15, minus, and then this becomes negative 2. Does this equal 13? It doesn't, because 15 minus negative 2 is actually 17. 17 is not equal to 13, so that this is not a solution. Solve if x and y are whole numbers. What we are trying to find here is a list of ordered pairs that are whole numbers. That means numbers that are integers and non-negative that work in this equation. Okay, your first step is to solve for y. So to do that I'm going to subtract 2x from both sides. And I get the equation negative 2x plus 6. Okay, that I'm going to plug in and use a table now. And in the table I'm going to start by listing values for x, and x is going to start at 0. And we're going to find the corresponding y value for that. Negative 2x plus 6. I'm going to see if I plug in 0 if I get another whole number answer for y. Well, if x is 0, then y is negative 2 times 0 plus 6. That's 0 plus 6 is going to be 6. So when x is 0, y is 6. Those are both whole numbers, so this is one of the solutions we're looking for. I'm going to create a list of them down here. So these are my solutions. The next whole number I'm going to plug in for x after 0 will be 1. When I plug 1 in, y will be negative 2 times 1 plus 6. This is negative 2 plus 6 will be 4. So when x is 1, y is 4. Both are whole number solutions, so that's going to go in my solution list. Next number to try for x, 2. If x is 2, y is negative 2 times 2 plus 6. It's going to be negative 4 plus 6, that is 2. Both of these are whole numbers, so 2 comma 2 is one of my solutions. Next number to try for x, I did 0, 1, 2. You guessed it, it will be 3. If x is 3, y is negative 2 times 3 plus 6. Y is going to be 0. Both of these are whole numbers, so this will also be in my solution list. Now, here's where it gets tricky. You say, well, I'm going to keep going and doing this forever and ever and ever. Not true. When I plug in 4, negative 2 times 4 is negative 8, plus 6, I get negative 2 as an answer. So when when x is 4, y is negative 2. Negative 2 is not a whole number. So this is not a solution if x and y are whole numbers. I can stop here as well because I know that if I plug 5 in or 6 in or 7, I'm going to continue to get negative numbers. This number is going to continue to get negative. Notice what happened here. It went down, it went down, it went down, it went down. So it's going to keep getting down. There are no other whole number solutions to these equations. So these 4. Here's another example. First step, solve for y. I'm going to subtract 3x from both sides so that I get 2y equals negative 3x plus 8. Then I'm going to divide both sides by 2 so that y equals negative 3x plus 8 over 2. This is what I'm going to use to set up my table. So I start with my x column. Y is equal to negative 3x plus 8 over 2. Start by plugging in x to be 0. If x is 0, y is equal to negative 3 times 0 plus 8, all divided by 2, and this value is 4. So if x is 0, y is 4. This is nice. This is a whole number solution, so I'm going to start creating my list down here. Next, I plug in 1. If x is 1, then y is equal to negative 3 times 1 plus 8 over 2. And this is actually 5 over 2, which is 2.5. 2.5 is not a whole number, so this is not a solution. Moving on to 2. If x is 2, then y is negative 3 times 2 plus 8 divided by 2. This is actually 2 divided by 2. It's equal to 1. So if x is 2, y is 1. That's a whole number solution. So I will list it with my ordered pair down here. Okay, next I'm going to go on to 3. Y is going to be then negative 3 times 3 plus 8 over 2, which is negative 1/2. Ooh, that's not a whole number either. And if I sit and think about it, when I plug in 4, I'm going to do negative 3 times 4 and get negative 12 plus 8. I'm always going to get a negative up at the top. The larger numbers I plug in for x, the more negative the numerator is going to be. So I'm going to conclude from right here that any number I try that's going to be larger than 4 is going to give me a negative in the numerator, and so I will not get a whole number solution. These two are my only solutions. One more example. X times y equals 4. I want to know all of the whole number solutions. Start by solving for y, and I'm going to do that by dividing both sides by x. So y equals 4 over x. Now I'm going to create my table. Here's my x column. Y is going to be 4 divided by x. And I'm going to start with 0. If x is 0, then y is going to be 4 divided by 0, which is a problem because that is undefined. I cannot find a value for y when x is 0. Moving on to the next one. If x is 1, then y is 4 over 1, which is 4. That means that this is a solution. One of my ordered pairs that are whole numbers will be 1, 4. Next, I'm going to move on to 2. If I plug 2 in for x, y is going to be 4 over 2, which is 2. So 2, 2 are both whole numbers, and it is one of my solutions. Moving on to 3. If x is 3, y is going to be 4 over 3, which is 1.3 repeating, or 1 1/3. That is not a whole number, so that is not a solution. Moving. When I plug 4 in for x, y is going to be 4 divided by 4, which is 1. 4 and 1 are both whole numbers, so this is another ordered pair that is a solution. Now if I move on to 5, it just seems like I'm going to keep going on here forever and ever and ever. But 5 is the one that kind of gives me pause to think that maybe I can stop. When I plug 5 in, I get 0.8. And 0.8 is not a whole number, so this is not a solution. If I think next about plugging in 6, I'm going to do 4 over 6. Well, that number is less than 1, and that's not a whole number, so that won't be a solution. As I plug in larger and larger x, this value for y is going to get smaller and smaller and smaller. I will never get another whole number that this could be. So right here are the only solutions to this equation that are whole numbers.